we spinning? Let's not spin. This is not that kind of a show. Hey, folks. DJ Singley here with MAPSYS. I'm coming at you today with another episode of NextGen IT. Today, we have a great episode. I'm talking with a friend and colleague, Sam Warner. It's IBM's General Manager of Storage Products. Today, we'll be taking a look at IBM's latest storage product, Storage Fusion. It's all about Red Hat OpenShift at its finest for all of your containerized and virtual workloads. So without further ado, let's dive into the webinar and learn a little bit together. Thanks for watching, folks, and we'll see you next time. Bye-bye. All right. Well, hey, folks. Appreciate you all joining. Really excited. Today we'll be talking about AI infrastructure that doesn't suck. Yes, an admittedly clickbaity title potentially, but I think it really captures kind of some of the themes that we'll be talking about here. If you have any questions today, please leave them in the chat, and Dan will get to them at the end. And I'm sure there will be quite a few questions. The last time we did this, we had overwhelming numbers of questions, so please be kind and gentle, okay? I am DJ Singley. I am the Chief Technologist at MAPSYS. MAPSYS is a 40-year-old technology IT partner headquartered in Columbus, Ohio. We serve the infrastructure field with a lot of IBM hardware as well as other things, but we also do staffing and recruiting and maintenance and software sales, and we even have a software design team that specializes in cloud and IBM software as well. Today with me, I have Sam Warner. Sam is the General Manager of IBM Storage. Sam, can you take a bow? There you go. So, Sam, I love that you joined me here today. And the bow was great. So I think the first question I want to lead off with is, can you explain your role in IBM and why AI infrastructure has anything to do with IBM storage and why the storage brand is so embedded in the discussion?
Yeah, great. And thanks, DJ. Really happy to do this with you today. And so my role at IBM is I'm responsible for the end-to-end IBM storage portfolio in the company, which is a very broad portfolio. But I have to say it's never been a more exciting time than now to be in storage. And I've been in storage a long time. When you think about everything happening with AI, the need to be able to unlock the value of an enterprise's data is critical to be able to get the value out of the AI. So obviously, as the custodians of data within our storage products, we play a very critical role there. I mean, when you think about the AI models that exist in the world that everybody's talking about, whether it's what you get from ChatGPT or Llama or whatever, they've consumed 99% of the world's public data, but only about 1% of the enterprise data. So as an enterprise or as a company that wants to deliver value to your clients or differentiate yourselves, the way you do that is by bringing your data now to these AI models. And that's where storage comes in.
Perfect. Well, Sam, there's a couple questions, of course, I have to ask, right? So, as you know, we have a kind of a shocking title. So I think the very first thing that most folks might look at is say, hey, so is a new investment in infrastructure on-prem necessary for AI? Why can't I, as a CIO, use my 5-year-old VMware cluster with 100 servers sitting there with my block-based SANs attached to it? Why do I need something new, either cloud or on-prem?
Well, there's a lot of reasons. Now, first of all, I think we see a lot of enterprises or companies out there starting in the cloud. That's an easy place to get started, right? You go sign up for a contract with OpenAI and you can start playing around, right? But then you find quickly that, number one, it's expensive. Number two, a lot of your data is on premises, right? Where are you currently running all of your applications and where is all of your key data? Because, of course, anybody can go to OpenAI and build an application directly on what OpenAI delivers, but that's pretty generic and it doesn't have new information, it's stale, and it doesn't have your information, it doesn't have the context of your enterprise, right? So when we talk about RAG and other techniques like that to bring your data, that's very difficult to do if all of your data is on-prem. That's number one. Number two, it gets pretty expensive to run in the cloud. So you might want to have a longer term model that brings it on-prem. Also, as you're building new applications in the future, they're probably going to consume AI services And so you have to think, if you want to be able to deliver those applications on-prem, they might want to consume those AI services on-prem. But then you asked a very important question, which is, can I just use my existing infrastructure? And the reality is, you could probably make some variants of something work there. But first of all, you're going to need GPUs. You can't do inferencing. You can't run large scale models on CPUs. You do need GPUs. You could probably see how much revenue NVIDIA is generating. That's for a reason. So you do need GPUs. And then you say, well, VMware is how we manage our environment. Can't we just keep running with VMware? But the problem is when you look at all of the AI frameworks, all the software, middleware, everything required to build and then run AI requires Kubernetes. So you start to think about, what does my new infrastructure look like? And then how do I streamline development so that as I build applications on AI, I can actually put them into production? So if you want to be successful in building and deploying AI applications long-term and delivering services that deliver value to your clients, you really need to think about a new architecture for doing that.
I'm glad you brought the Kubernetes piece, right? So many of our customers feel that that is a little bit of a science experiment in and of itself. Wouldn't you agree?
Yeah, well, I mean, it's new.
Yeah.
And VMware spent many, many years perfecting their platform. And I won't take anything away from VMware. It's fantastic, right? I mean, most of the world's infrastructure is deployed using VMware. And they
Okay.
did a lot of things that made it such a pervasive platform. Like, I'm a storage person, so I'm going to go there, standardizing the way storage is deployed and behaves. And they gave the VM administrator the ability to have visibility and management of their own infrastructure, right? Putting the infrastructure team off to the side to just deploy capacity, the VMware admin was able to do a lot of their own work. Now bring Kubernetes, it's a whole new world, right? And you have to refigure out some of these pieces. And a
Yeah.
lot of times you don't have the skills. Like, how do I attach storage to a Kubernetes cluster? What does the networking need to look like? How many cores do I need? How many, right? Like, how much memory? How much can I deploy per? Now you're deploying a cluster of shared compute. There's a lot of new techniques. And now it's not a VMware administrator, it's a Kubernetes administrator or architect. And the application developers have different expectations. So it's like a lot of new stuff to learn. It changes your run books. It's not the same.
Mhm.
And I'll talk a bit when we get there about how I make that easier for you by giving you consistency in how the infrastructure is deployed and helping you with everything from day 0 to day 2 operations. But it's not just a simple transition. There is new learning. There are new skills required. But once you get there, it can be just as easy, if not easier. Definitely easier for the application developers.
Okay. Okay.
Yeah.
Well, when I hear Kubernetes, I hear OpenShift. So maybe you
Mm.
could touch upon why IBM bought Red Hat and why
Yeah.
a container native solution is the optimal architecture and really the only place to go.
Yeah, that's great. And thanks for keeping me honest. I probably should have
Yeah.
been saying OpenShift more in that, but
It's okay.
look, when you go back to when IBM acquired Red Hat, I mean, primarily it was a focus on OpenShift. We viewed the future to be hybrid cloud infrastructure and still do, right? And in order to really deliver on the hybrid cloud vision, it's not about bursting necessarily in and out of cloud. It's about a consistent operating model. So when I deploy or build applications on-prem and I deploy or build applications in the cloud, it's the same operating model. So my development teams don't have to build applications in different ways. That's not the reality of like the way traditional infrastructure works. The
Right.
cloud is scale out, it's simple, it's different middleware than what you get on-prem, which tends to be scale up and highly optimized. Kubernetes gives you that consistent way of doing things. And if you remember at the time when IBM acquired Red Hat, everybody was building a Kubernetes distribution, including IBM. We had IBM Cloud Private, and we had a lot of success with that with our clients. But when you looked at who had been doing it longest and who really was most mature in building, I mean, you can say Google was building Kubernetes first and longest, but
Sure.
when you look at who was really building a commercial model to help the enterprise deploy on-prem Kubernetes, OpenShift was far, far ahead of everybody. And we knew it was this critical future operating model. And we've seen that come to fruition if you look at the success we've had with OpenShift. So we acquired Red Hat and we made it part of everything we did. In fact, we went and took the entire IBM middleware portfolio and made it all container native. In fact, when you buy and deploy IBM middleware, you mostly do that on OpenShift today. And OpenShift has ultimately become the de facto standard on-prem. It is past the market share level where there's really any question about it. I would call it the RHEL, like RHEL is to Linux as OpenShift is to Kubernetes.
Oh, good, good, good. Well,
Yeah,
that's perfect. So I think that leads us sort of into sort of where I want to really ultimately go with our conversation, and that is to IBM's Fusion product. So IBM has a very unique product here, Sam. I think I'd like to call it AI in a box, which just came up in a conversation just the other day, and I like that tagline. I think it's very useful and it can be
yep,
used here. Can you take our audience through the IBM Fusion HCI's appliance approach to OpenShift?
yeah.
Maybe some
And
slides even.
I also like the AI in a box.
Yeah.
Yeah, that's what we're trying to do, right? Because AI is new to most people, and they're still figuring it out, and we want to help make that easy.
Right,
Uh,
right.
so let
Kubernetes is a
me,
science experiment, and maybe this will help you out, keeping
yeah,
it not so sciencey
that's right.
and experimenty. So,
Okay, so look, there's like 5 different challenges that I usually talk about with clients, or they talk about with me, and I spend a lot of time with infrastructure teams. So a lot of what I'll talk about will be, somewhat slanted towards that. But the things that they're challenged with all kind of revolve around the thing in the middle, which is AI. Obviously, it's the topic, the most important topic probably right now as people think strategically where they're going with IT, right? We have to make sure that we're keeping up so that we keep a competitive advantage or build a stronger competitive advantage in whatever industry we're in. But in order to do that, you have to look at all of the challenges in order to focus on AI. So when you think about efficiency, this is a big challenge. You have high data growth. I don't know anyone who doesn't have high data growth, primarily unstructured data. It's expensive to figure out how to manage and store this data. And most enterprises also have a big challenge around data silos and how to bring all this data together, clean it up, understand what you have. And skills become a big challenge in all of this, right? How do you maintain the right level of skills to manage the life cycle of all this data? So, and ultimately, if you want to invest in AI, which is not cheap, I think most of us know that, whether you do it in the cloud or on-prem, there is an investment that needs to be made. It's not free, and so you need to optimize what you have. Okay, so that's number one, efficiency. You have to figure out how to be efficient with all this data. Number two is VMware, and of course, Broadcom bought VMware, and there's a lot of concern about cost increases because of that, and lock-in and all of the other things that come with that. But this transition away from VMware and traditional VM type environments was already in progress because people realize the new, and back to the whole hybrid cloud platform thing I was talking about, in order to streamline how you develop applications and really have the flexibility of building in the cloud or on-prem with the same DevOps model, the same security ops model, you really need to have a consistent environment. And that's really what I think of when I think of hybrid cloud. And so people are already moving away from traditional VMware to Kubernetes. We've seen enormous growth in Kubernetes adoption. But then that brings me to this AI piece, which is when you look at AI, all the frameworks, all the middleware, everything that goes with building AI is all deployed on Kubernetes. If you go look at the NVIDIA stack, it's all built on Kubernetes, right? So if you want to start building applications that are AI based or, whatever, AI applications in general, you need to be able to build those on top of Kubernetes. So even if you're not ready to start building AI on-prem yet today, you still need to be able to build out a Kubernetes type infrastructure. You need to be able to support the DevOps tool chains and all that go with building on top of Kubernetes. If you were to ask me, and many of you have probably heard of things like agentic AI, which I'll keep it simple. To me, agentic AI is kind of a new, like the next generation of API. You don't actually code something to an API and have to understand everything about an application. Instead, that application, that infrastructure, whatever we're talking about, has an agent. And your agent asks that agent to tell it, describe the API or how to talk to each other. And then they do that. And that becomes the way of doing APIs in the future. Think about how much more simplistic that is as you want to integrate more components, if you want to streamline support, whatever it is. You want to streamline how you manage your infrastructure. Imagine just being able to type in, I'd like to provision this volume on this cluster, and it says, here's the steps to do that. Would you like me to execute it? And you say, yes, do it. Think about that from an agentic AI perspective. So if you think about everything moves towards this agentic model, I would imagine 2-3 years down the road, most new applications being built are going to consume AI services. And if that's the case, then you're going to need to be able to deploy infrastructure that supports building and deploying AI underneath, right? You're going to have GPUs are going to be a requirement for a lot of your applications, at least for some of the services they're consuming. That brings me back to why there's a need to have GPU infrastructure on-prem, ultimately, unless you're planning on putting everything in the cloud. So I think we'll see more and more of that. But then you have to think about, is that infrastructure highly available, right? So I can't just, what we see happening in a lot of cases is the AI teams are just building on whatever, and they're not thinking about how do I build highly available infrastructure that's can be backed up so that I can ensure my application's always online. And that's going to be a problem when you think that some of this AI is the middleware of the future. Okay, so the AI piece is clear. The hybrid cloud piece here, I think, is pretty straightforward. After that, I've already talked about it quite a bit. I'm going to be deploying applications on-prem and in the cloud. I need a consistent model. I need data availability to where I'm deploying my application. And I need to be able to consume AI services probably, or connect with agents running both in the cloud and on-prem. And then the last piece I just alluded to, which is around, if these applications, if you are replacing internal business processes with AI, if you are delivering new applications to your clients with AI, all that stuff needs to be highly available, like an Oracle database today, right? If the application is down, you can't do business, you can't manufacture, whatever it is you replaced internally, right? Your business is at a halt, a standstill, or your application that you deliver to your client is offline. So how do you keep it highly available? And then you have to think about cyber attacks and everything that goes with that, which I assure you, there's a lot of risk being created today in a lot of the way AI is being done. Because how do you do it today in the cloud when you need your data? You copy all your data into the cloud, and then you put it through some transformation process, and then it's in another database. Have you maintained all of the ACLs for that data through that process? Have you ensured that data is secure and you have no PII? There's so much risk in the way things are being done today. And eventually, this all needs to be brought under control into a more manageable model. So, a lot of challenges, DJ, for sure.
Yeah.
But that brings me to what we're doing. Well, one more point, like if you look at a typical enterprise environment, or pretty much anybody's, you have, I mentioned the silos of storage. You've got all these different types of storage, all independently managed, lots of different users, don't really know what's out there. That's a challenge, very fragmented. And then you typically have a fragmented infrastructure team. You have a compute team, a network team, a storage team, all working independently. And then back to the question you asked earlier, DJ, I mean, VMware helps a little bit with that, but as you get into Kubernetes, some of this can become more challenging. So you see a lot of enterprises starting to build what they call platform engineering teams that kind of figure out how to unify these pieces.
Okay.
So that we can simplify. This is where IBM is going. We are trying to build an enterprise. We are building an enterprise AI-ready infrastructure platform to simplify all that. Unify the silos of storage, unify networking, storage, and compute, bringing clear, pre-tested patterns that you can deploy. So first of all, at the base of it, we have a global data platform, which allows us to connect to all of your external storage sources and unify that data through abstraction with a single namespace. I'll come back to that. Above that, we have a set of AI-enabled data services. So, for example, if I have data sitting out in object storage in Amazon, I have my NetApp NFS filer on-prem, and whatever else, wherever else I have data sitting, I can get visibility to that data. I can give you a single namespace to address that data. And then using my AI-enabled data services, I can actually vectorize that data for you. So for those of you who don't know anything about RAG, which is how I won't get too much into the technical details of it, but it is the way that you bring your data and apply it to an AI model. So if I ask an AI model a question, if I use RAG, I can apply my data so that that context is included. It changes the weighting of the answers and also provides my information. And the way you do that is you take all of your data, you put it through an AI model in order to create vectors, which are basically floating point representations of your data, and they go into something called a vector database. So that vector database is then used as you inference an AI model to apply your data to the model. Okay, so you need to vectorize the data. Now, doing that, like I said, that is an AI model on its own. What most people do today is they copy it off the server they copy it off the storage into a server and they run an AI model. Okay. So we deliver that vector database internally and keep it up to date at all times. And we deliver other things like KV cache, which allows AI models to remember context. So today, if for those of you out there who use things like Claude or ChatGPT or whatever, you go have a conversation with ChatGPT and it follows up and you have a little conversation, you leave and you come back later and you ask it a question again, it gives you a completely different answer and you're in like a whole new conversation. And sometimes you just wish you could get back and finish the rest of what you were talking about before, but you're like starting from scratch all over again. What this is it allows an AI model or AI application to store the context. You can't do that today because there's not enough cache in the system. KV cache allows that context to be saved out onto storage so that it can be retrieved and you can resume your context, which significantly lowers the number of tokens required, which any of you who do AI know dollar per token is how it's measured and it's expensive. It reduces the number of tokens required, allows you to maintain context without having to redo a lot of the work. And then we offer the full stack services and automation, which is really important, day 0 through day 2. I give you the backup, the high availability, the storage management. You need to update versions of OpenShift or a new version of VLLM for running your inferencing runtime. I manage the complete update of the stack. So you don't have to worry about, is my storage on a level that supports this version of OpenShift, which, like everything you can imagine that would break in that stack, we already have validated and we do the entire update for you. In fact, if you have multiple applications that require different versions of Kubernetes, you can actually run 4 different versions of Kubernetes on our platform at the same time. That way you don't have to worry about all these different applications always having to be compatible with the entire Kubernetes stack. So we give you a lot of flexibility there.
Sam, could you touch on just a tiny bit, just real briefly on the content-aware storage piece, where when data is generated, it can be almost immediately available for the AI model for inferencing? How you do that?
Yeah. Let me explain a little bit more. So
Okay.
what most people do today is they take all the data that they need in their vector database and they copy it to a GPU-enabled server. And they run it through a transformation model. Usually they use NIMs from NVIDIA, and it encodes the data. So they have to run it through this AI model. It requires GPUs to do that, and that gives them the vectors which go into the database. That vector database has no connection back to the original data source. So if data changes in the original data source, it doesn't get updated in the vector database. And even worse, there's no connection to know, like, which data to run back through. So most people throw out the entire vector database and start over on some frequency. And beyond, so they have to run all that data through again through GPUs, which is expensive. But more importantly is a lot of enterprises have more data than they can get through that pipeline before the data becomes stale and they have to throw out the vector database and start over. At IBM, just to do IBM.com, it would take us a week to get through 8% of the data. 8% of the data took a week. And then we threw out the whole thing and would start over. This was before, of course, they implemented our content-aware storage capability. They'd throw out the database and start all over. They could never get through more than 8% of the data. With something like content-aware storage, every time the data changes, we put it through the model and update the vector database in near real time. So to your point, DJ, if I search something, and I think you've probably all done it. Last year, I was doing fantasy football and I asked a question for ChatGPT thinking it was smarter than me, which it probably is at fantasy football. And it gave me an answer that was so ridiculous because it was about a player who was on a team like the year before. It was like just so wrong,
I had no idea.
so outdated. But
Yeah.
but the point is I can make a change to a file and it's immediately the next time I ask a question of the AI, I get a different answer like that. And that's really important. But also, if I change permissions on a file, the permissions change in the vector database in near real time
Mhm.
because most companies are completely disconnected between the source and the vector database, which means you might have data that should not be available to anybody and is being accessed by whomever searches on it. And that's a huge problem.
Sure.
So hopefully I answered your question there,
Yeah,
DJ.
you did. Yeah,
Yeah,
yeah. Thank you. There's a few customers out there listening that I know are very keen on this one topic. Some
yeah.
of the things we're doing that I'll touch on just very briefly later, this would affect them. So thank you.
Cool. Yep. And so then we package this whole thing up like hyper-converged infrastructure. We have the compute, storage, networking, pre-sized for you, tested with OpenShift, tested with OpenShift AI, tested with NVIDIA, tested with the NIMS models, but also with others. You can run Llama, you can run the Granite models, which we've open sourced through IBM and Red Hat. You can pretty much run any model you can think of on this platform. And we've done a lot of testing for these different things. So you don't have to worry about, number one, how do I design it day zero? How do I deploy it day one? And how do I run it in a high availability way where I'm backing up and prepared to recover if something happens? So,
Sure.
um, and I won't spend a ton more time on this because I think I've hit the majority of the points. But as I said, at the core of this, we have what we call this global data platform. And this allows us to abstract your existing storage. So some other vendors out there will talk about how they can do things like data pipeline. And all you have to do is replace 100% of your storage with their platform
Right.
and completely re-architect
Yeah.
everything with their platform, and you're good to go. We don't ask you to do that. You deploy our Fusion platform, you drop it in, and it has some internal storage, of course, where you can run and store and it has a vector database inside, and we provide that service that we call content aware storage. But we'll connect to any object store you have in the cloud on-prem, any NFS share you have on-prem in the cloud. We'll connect to those. They can maintain their persistence. You run your applications where they are. If you want to bring it in, you can. We provide internal storage for that purpose, or you leave it where it is. We will bring it in, we'll vectorize it, and we'll make it available. We have GPU Direct, so we give you the high performance access to your GPUs when you're running your applications. And GPU Direct also works with your KV cache capability.
Okay.
So if you're running your AI models, you can write out a very high performance into our storage. So we provide all that, but we also provide object interface so that you can run more modern applications on here. And we also connect to things like HDFS to provide you with access to existing Hadoop clusters or Spark clusters or whatever you have. So we're able to unify all the data. And if you're not ready to run AI yet, we provide at least just a really great container platform so you can start building and deploying your applications now with the ability, like I said, if you want to build AI applications, it's going to be on containers. We give you the ability to start building and deploying containerized applications. In the future, you can bring in GPU nodes if you want. I talked about content-aware
Oh,
storage.
you did. Oh, good. Yep.
I mean, I think you get the idea of what this is. We do in real time, every time data changes, we keep track of it, we chunk it, and we transform and vectorize it, and we keep a vector database. So when you think about traditional storage, it provides NFS, right, which is network attached storage. We provide, object storage, interfaces, so like an S3 protocol, POSIX, whatever, right? Lots of different storage protocols. But what's new here is not only does the storage provide the traditional storage protocols, it provides a search protocol So you can actually search on the data directly because we provide the database. So rather than pulling all the data out of storage to do the transformation and make it searchable, we instead do it inside the storage and provide that API. And I think you'll see that other types of content repositories will be doing the same thing. If you use Box or OneDrive or SharePoint, you know how hard it is to find your files within those. Imagine if they did the vectorization internally as well and made their platforms completely searchable. I think you're going to see that more and more across anybody who does content repositories, and that includes storage. Why shouldn't you be able to just search your storage? Why should you have to be able to bring all the data out to do that? So that's what we're doing with content-aware storage. So I'll just leave you with this. Fusion, the Fusion appliance, which is AI in a box, it's also just containers in a box, if that's where you're at in your journey. You don't have to worry about if you have the skills to build a Kubernetes cluster. We've already done it for you. It's fully tested with OpenShift. This is OpenShift in a box, and it's AI in a box. So this is turnkey. I've sized it for you. Get small, medium, large. Drop it in, fully tested. Every release of OpenShift, we are right behind them with the updated version of this. We support multiple deployments of OpenShift in a single cluster, so you can have lots of different deployments of OpenShift. You don't have to worry about the networking config. You don't have to worry about how the storage is going to behave with its CSI driver, which is how you talk to storage in Kubernetes. You don't have to worry about all that. We have DR built in, high availability built in, backup built in. Our backup is container aware and application aware for applications that we've integrated with, which is quite a few. But we also give you the ability to build open source recipes, which you can share with other clients or they can share with you, which make whatever application you have or want application aware backup as well. And then really the biggest thing is when it comes time to do upgrades and manage the life cycle, do repairs, we've taken care of all that. So you talk about VMware being easy. We've made Kubernetes extremely easy. And then you can add in your GPUs, which we can provide, the GPU nodes, and you can run your AI inferencing right here. We have the vector database services, and we don't require you to bring all your data in. We will abstract and virtualize all of your external data sources. And we've, like I said, are fully tested with VMs on OpenShift. So if you're just looking to get off of VMware or have an alternative and you're not ready to move everything to containers, and by the way, I don't think you ever will, you can come onto this platform. You can land your VMs as OpenShift VMs. You can start deploying containers, and you can bring in AI frameworks, including watsonx, which we're fully tested on. But of course, we test with other stacks as well. So that's what Fusion is in a nutshell and what we're working on. It's really, I know we said I'm from storage, but we're obviously doing a lot more than storage. This is a complete infrastructure platform.
Yeah, it really is. Can you just touch real briefly on the Ceph or the Scale software used as the storage layer here?
Yeah, I mean, so actually, why did we call this product Fusion?
Perfect.
IBM has some incredible technology, and we've brought it together to deliver in a single platform what you need to deploy modern workloads in containers and for AI. And Scale, which has a very rich history as a cluster file system for high performance computing. If you think about what AI is, in a lot of ways, it's very similar to HPC. HPC is a cluster of compute, right, that breaks up a workload across multiple nodes that needs access to the same data, and they need a cluster file system to do that. Same thing can be said for AI. You're breaking up a workload across a bunch of GPUs. You need shared access to files. You need to be able to write fast checkpoints, and that's what Scale provides. Ceph is one of the world's leading cloud-native software-defined storage platforms. It was built for OpenStack back when people were looking for how do I deploy cloud-native storage on-prem outside of what the hyperscalers are doing. And that's what Ceph became. It's open source, it has a really rich and vibrant community. And after we acquired Red Hat, we moved the Ceph technology into IBM because we saw this opportunity to build out this platform. It is under its container native version, which is called ODF or OpenShift Data Foundation. is by far the leading storage for OpenShift deployments. In fact, to the point that Gartner doesn't even consider container native storage to be a market anymore, because the large share of deployed persistent storage for Kubernetes and OpenShift is OpenShift Data Foundation.
Yeah.
And all those technologies are built right into this platform.
Yeah.
Simplify it and give you the services.
I love it.
Yep.
It is a good platform. In fact, my very first opportunity that I was working on recently has been to replace VMware. A lot of people are mad at VMware. Gee, I wonder why. So, Sam, in the interest of time, I want to ask you another question and then open it up to our audience for questions. So, Sam, if you had one blunt piece of advice for a CIO or any leadership in a company looking to do AI software and hardware infrastructure, what would it be?
Just one, but I think it's a good one.
Just
I would learn the lessons that we learned during the Hadoop
Ooh,
craze
yeah.
or whatever you want to call it.
That's still a
If you
thing,
all
Hadoop.
remember, if you were around, when Hadoop first took off, it was built by the business lines, totally independent of the infrastructure teams. And in fact, I would go into the infrastructure teams and ask them, what you're doing with Hadoop and, how's your experience going? What are your challenges? And they'd go, Hadoop, we're not doing anything. And I'd say, well, I know your organization is, no, we're not doing Hadoop yet. And I'd be like, I literally, we're IBM is selling them Hadoop software. So I know they're deploying it. And ultimately what happened was they ended up with these clusters that were, call it 20 petabytes of Hadoop. There was no data governance, no ability to do high availability, no backup, no thought on how to manage the life cycle of this thing. Costs ballooned out of control because the architecture wasn't thought out. And ultimately, that whole thing blew back onto the storage team to try to figure it out. It was never designed up front. And I've seen this happening with containers as well, where middleware team is off, not middleware team, application development team is off saying, I'm going to go build applications. Strategically, our DevOps environment is going to be built on Kubernetes. We see that as the future. They go get a bunch of Kubernetes, containerized middleware. Then they go to the infrastructure team and just say, hey, I need 10 VMs because I'm deploying something. And they go deploy Kubernetes on top of that. And they start building their applications and they streamline everything. And then they realize they can't back them up. It doesn't scale, right? They have all kinds of problems, no idea how to do high availability. And now the infrastructure teams are scrambling, trying to learn about Kubernetes and how to build the right architecture. So long-winded answer to a fairly simple question, but it is that the infrastructure teams and the AI teams need to be talking now. You have to build the right architecture for this. You have to think about hybrid cloud, I believe, if you want to be able to long-term get the value out of what we're trying to do. If you're trying to improve operational efficiency and save money through AI, then you have to be cost-effective in your AI. If the AI costs more than the way you were doing it before, it's not exactly improving efficiency. And if you're delivering applications to your end users, you have to be able to do that in a cost-effective way. But more importantly, you have to be able to deliver a quality service, which means data needs to be current, depending on your application.
Yeah.
And the application needs to be highly available.
Perfect. Thank you for that. I do also have plenty of customers using watsonx right now in the cloud that are looking at bringing it back on-prem for all of the reasons you just went over.
Yeah.
And I do believe eventually that will even lead to better ROI for them as they continue down their AI path. So Dan's back with us again. So Dan, I hear we have a bunch of questions coming in.
Yeah, I got a few questions coming in. So for anyone interested in asking a question, please go ahead and type it below. If you click where it says Q&A on the bottom, it'll give you an opportunity to ask a question. But a couple out of the gate. So one person's asking about bringing their own hardware to a Fusion cluster. Is that an option?
Well, let's see. We do have a software-defined version of Fusion, so you absolutely can do that. We also operate Fusion in what we call control tower mode, which means you can deploy our HCI version of it, and we can extend the management beyond the HCI. So there are ways to do that. Though I will tell you the value prop that I talked about, largely comes from the fact that we have fully tested the stack. My recommendation usually is to take Fusion HCI as it is. I think it's the best experience, but we do offer different modes where we can support your existing hardware.
Good.
Good question.
Anything else?
Awesome. So another question, is Fusion good for just training models or just inference, or what all does it support?
Look, I'll say this. I don't think most of you are going to be training models. Like, there's really, really good models out there. Why waste your resources on that? What it's really, I think really what you want to figure out how to do is pick the right models for what you're trying to do. You don't always want the biggest model that does everything. If you can find a model tuned to your use case, it'll be way more efficient. Less parameters, meaning it requires less GPUs, and it'll be cheaper. So I think you're going to pick models to do what you need them to do. But generic models aren't good enough. Of course, it needs the context of your business. Look, you're in some industry, and your competitive advantage, what prevents you from being disrupted, is your institutional knowledge of your customers and your industry. But if you can't bring that information to AI, then you have no differentiated value. So to me, the point of Fusion is about inferencing. We can run pretty much any model you go find. You bring that model, and then we help you bring your data, and we give you the operating environment to do that. So to me, it's all about inferencing. And one more comment on it. If you follow, Jensen, if you go to GTC, if you're, really into this stuff, at GTC this year, which is the big NVIDIA conference, Jensen called this the year of inferencing. Right? This is where the AI innovation is now. Like, the big models are trained. They're out of data, by the way. 99% of the world's data. They even transcribed YouTube videos to get more data to feed their models. Now it's really about inferencing.
Yeah, I'd agree with that. I would just add real quick though, for my Maximal Visual Insight customers out there that are using these kind of clusters to do some very basic training of their models. Yes,
Yeah.
they're good for this. So
You can. I agree.
you can. Okay. All right, Dan, what
Beautiful.
we got?
What else we got? So can I use Fusion to connect to an ISCSI or fiber channel SAN?
iSCSI or fiber channel. Yeah. Okay.
iSCSI.
Good one.
Yes, we do give you the ability. If you have existing SAN storage infrastructure, we give you the ability to make that container native and bring it into a Kubernetes cluster through a capability we call Fusion Access. That can be over fiber channel or iSCSI, I believe.
Okay.
The one thing I will tell you is the abstraction piece I talked about. That's really an unstructured data type of concept, right? But you can absolutely bring that storage in and make it usable storage as part of your Kubernetes cluster. And in fact, what we're finding is a lot of our clients who have large VMware deployments have a large SAN infrastructure underneath it, right? And they don't want to throw that out and start over. However, if you move into Kubernetes, say virtualization, OpenShift virtualization, it's very hard to use traditional SAN in that environment because of the scalability differences and how it works. So what we do with our Fusion Access is we actually make that storage seem container native, and we take care of all the scalability issues you'd have and make it really easy to preserve that investment you have in your existing SAN infrastructure. You do not have to throw it out. We make it really easy to make that transition.
It's great. It's a great benefit for IBM right there for sure. Dan, you look like you're mute.
Sound better that way. Let's see here. Ken, I thought Ceph was part of Red Hat, not IBM.
Oh, me too. No.
Oh, great. Now we're all confused.
Yeah, I think I might have already addressed this, but yes, when we acquired Red Hat, Ceph was part of Red Hat, and a few years ago, I don't know, 2-3 years ago now, we decided to move Ceph into my portfolio, and the primary reason for that is Ceph within Red Hat had always been a means to support the strategy for OpenStack and then OpenShift, which is extremely important. And that's why Ceph is so good at OpenShift, by far the best. But we thought the opportunity was larger than that. And we are a storage business, and we wanted to bring more value to clients with Ceph. So we've built onto it. We've added NVMe over TCP support so that it can act as a scale-out block storage solution. We have large customers deploying it that way, and as an object store independent of those platforms. And we've brought back the NFS and SMB protocols. So we really see it as this general scale out, cloud native storage platform. And we even now offer it as a service. If you wanted Ceph deployed in your data center, we actually will drop it into your data center, be managed by IBM SREs. And all you do is pay for how much capacity you use. So you provision it to your heart's desire. Feels just like having cloud storage in your data center. It's your own version of EBS and S3 in your data center. If you're an Amazon user, and it's just always on and ready to go. And you just, pay for usage. No skills required.
Good.
Beautiful. All right, I'm down to one last question. So if anybody has, it's the last call for questions, and then VMware virtualization is way too expensive now, but it's the easy button. In my past experience, OpenShift was too complicated. Is Fusion any better?
Yeah, I mean, it's nothing against. Kubernetes, as I mentioned earlier, is a new way of operating, and it requires a new set of skills, and so it does take some learning, right? And then if you deploy Kubernetes out of the box, then you're dealing with storage behaves in different ways and networking. And you have to really understand all those pieces. Fusion does take care of that because we make it simple, turnkey, day 0 through day 2. No challenge with backup, no challenge with DR. It's simple, and we've designed it for you, so you don't need the skills.
Perfect. Yeah, I like that. That was lively questions. I like it. Nothing too hard, right? So good. Well, great, Sam. I think that about does it for us. I want to thank the folks that have joined us today to discuss this topic, AI infrastructure that doesn't suck, and we've certainly figured out what doesn't and what does. So, love IBM Fusion. So, thank you again, Sam, for your time today. We look forward to doing this again sometime soon.
Thanks, appreciate it.
All right, you're welcome. Yeah, thank you, Dan.
All right.
Thank
Everybody
you
have a
for putting this
wonderful
together.
rest of your day, and we'll follow up. And DJ and Sam are always happy to answer questions in the future.
All right, thanks.
Sounds good. All righty, we'll see you folks.